It's Caesar the Circle Ape one last time talking to you about circles in the coordinate plane. Thank you for watching these videos. Maybe you will be spared when the apes revolt.
First thing we're talking about are circles in the coordinate plane. So an equation of a circle with center h, k and radius r is x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared, where again, h, k is the center of your circle and r is going to be the radius of your circle. Now if you take a look at our example down here, we have a circle with a center at the origin, 0, 0. Its radius is 10 units. Therefore, if I want to write the equation of this circle in the coordinate plane, it would be x minus 0, the quantity squared, plus y minus 0, the quantity squared, is equal to 10 squared. Because again, your center is at 0, 0, and your radius is 10. So over here, we can simplify this. X minus 0 is just x. Here, we can simplify this. Y minus 0 is just y. And then 10 squared is 100, giving you this equation, the equation of this blue circle right here.
Caesar hates humans, but Caesar loves circles. Example time.
Now example 1 says write the equation of each circle. So we have a circle with a center at 2, 4 and a radius of 5. So these questions are super easy. You just need to remember the equation of a circle in the coordinate plane. That would be x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. Now we just plug in what we know. We know our center is h, k, so we're going to plug in 2 for our h and 4 for our k. Our radius here is 5, so we plug in 5 for our r. Then we simplify whatever we can simplify. X minus 2, that's just going to stay x minus 2. Y minus 4 is going to stay y minus 4. 5 squared becomes 25. And you're done. Part B, doing the same thing. We are given the center and the radius, so if we want to write the equation of a circle, you just need to remember the equation of a circle in the coordinate plane. That would be x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. Up here, we are given our h and our k, so we're going to take -1, plug it in for h. We're going to take 8, plug it in for k. Our radius is 7, that's going to go in here. Then we just simplify whatever we can simplify. X minus -1, we can rewrite as x plus 1, the quantity squared, plus y minus 8, that just stays y minus 8 squared, is equal to 7 squared, which is 49.
Why don't monkeys play cards in the jungle? There's too many cheetahs! You try! Ho!
Okay, doing the same thing. We are again given the center of our circle and the radius, and we want to write the equation of each circle. So we need to remember the equation of a circle in the coordinate plane. X minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. Up here, we are given our h and our k, so we're going to take 0, plug it in for h. We're going to take this 0, plug it in for k. Take 2, plug it in for your radius. We then simplify whatever we can simplify. X minus 0, we can just rewrite as x. Y minus 0, we can just rewrite as y. And then 2 squared gives you 4, and you're done. Part B, doing the same thing. We're given a center and a radius and tasked with writing the equation of our circle. So what is the equation of a circle in the coordinate plane? That would be x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. Up here we have our h and our k, so we're going to take -7, plug it in for h, take -4, plug it in for k. Our radius is rad 5 this time, so we're going to take rad 5, plug it in for r. Then we just simplify whatever we can simplify. Over here, x minus -7, we can rewrite as x plus 7. Then y minus -4, we can rewrite as y plus 4. And rad 5 squared. The square and the square root just cancel each other out, and we're left with 5. Now example 2 says write the equation of the circle with the given center that passes through the given point. Now remember, in order to write the equation of a circle, you need the center of the circle and you need a radius. But we don't have the radius, we just have a point on the circle. Well, is there a way we could find the radius using these 2 points? Well, yeah, isn't the radius of a circle just the distance from the center of a circle to a point on the circle? Yeah, so how do we find the distance between these 2 points? Well, we use the distance formula, which is the square root of x sub 2 minus x sub 1, the quantity squared, plus y sub 2 minus y sub 1, the quantity squared. Now, that distance between these 2 points should give you your radius. So let's fill out this distance formula. To do that, we need to pick one of these points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. So I'm going to plug in these coordinates to their corresponding spot in the distance formula. I then simplify and I get our radius is equal to 4. So because I have the center of the circle and I have the radius of our circle, I can write the equation of the circle in the coordinate plane, which is x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. My center is h, k, so I'm going to take -2, plug that in for h. I'm going to take 6, plug that in for k. My radius is 4, so I'm going to take 4 and plug it in for r. I then simplify whatever I can simplify. X minus -2 is the same thing as x plus 2. Y minus 6 is going to stay y minus 6, and 4 squared is 16.
What did the monkey bring to the party? Chimps and
Okay, doing the same thing. I'm again given the center of a circle and a point on the circle. But in order to write the equation of a circle in the coordinate plane, I need the center and a radius. So how do I find the radius here? Well, remember, the radius is just the distance between the center of the circle and a point on the circle. So how do I find the distance between 2 points? That's the distance formula. And we know what the distance formula is now. Whatever that distance is between these 2 points will give us the radius of our circle. So we choose one of our points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates to their corresponding spot in the distance formula. We simplify and we end up getting a radius of rad 52. Now rad 52 is not a perfect square, so we have to break this up. Remember, this says leave your answer in simplest radical form if necessary. So the square root of 52, we're going to have to break up into 2 radicals that multiply together to make rad 52, one of which is a perfect square. That's going to be rad 4 times rad 13. The square root of 4 becomes 2, rad 13 stays rad 13. So the radius of our circle we know is 2 rad 13. If we know the center of our circle is 7 comma negative 2, we can then write the equation of our circle in the coordinate plane, which is x minus h the quantity squared plus y minus k the quantity squared is equal to r squared. Now all we have to do is plug in what we know. We know the center of our circle is h comma k, so we're going to take 7, plug that in for h, take negative 2, plug that in for k. Our radius we said was 2 rad 13, so that's going to go in for r. Now we simplify whatever we can simplify. Here, x minus 7 stays x minus 7. Y minus negative 2 we can rewrite as y plus 2. And then 2 rad 13, the quantity squared. This trips up everybody. All you have to do is just square the 2 and square the rad 13. So what is 2 squared? That's 4. What is rad 13 squared? The square and the square root just cancel each other out, giving you 13. So to finalize our equation of the circle in the coordinate plane, we just multiply the 4 times the 13. You get 52. Part B, we're doing the same thing. We're given the center of the circle and a point on the circle. So to write the equation of a circle in the coordinate plane, you need the center of the circle and you need the radius of the circle. So to find the radius of the circle, which is all we have to do, we need to find the distance between the center of the circle and a point on the circle. Because we're given 2 points and we need the distance between them, we're using the distance formula. So the radius of our circle is going to equal the distance between these 2 points. Now all we have to do is plug in these 2 points to the distance formula. So we choose one of the points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in their coordinates to their corresponding spot in the distance formula. Simplify, we end up getting the radius is equal to the square root of 36 plus 25, which is the square root of 61. And because 61 is a prime number, we just leave it like that. It can't be broken up any further. Now that we have our radius and the center of the circle, we can write the equation of our circle in the coordinate plane, which is x minus h the quantity squared plus y minus k the quantity squared is equal to r squared. The center of the circle is h comma k, so we're going to take 6, plug it in for h. We're going to take 5, plug it in for k. The radius of the circle is the square root of 61, so we plug that in for r. We then simplify whatever we can simplify. X minus 6 stays like that, y minus 5 stays like that, and the square root of 61 squared, the square and the square root just cancel each other out, leaving us with 61. Now example 3 says find the center and radius of the circle with the given equation, then graph the circle. So we are given the equation of a circle in the coordinate plane and we need to extract the center and the radius, and then we can graph that circle. So the way we're going to determine what the center and radius of this circle are is we're going to compare this equation to the equation of a circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared equals r squared. So all we have to do is compare each of these equations and we can figure out what our h value is, what our k value is, and what our r is. So we're going to start with h. This is supposed to be in here x minus h, and we have x minus 1, meaning h is going to be equal to 1. That was easy. Over here, this is supposed to be y minus k, and we have y plus 5. Oh, interesting. So what would k have to be in order to change the sign here? Well, it would have to be negative, meaning our k value is going to be equal to negative 5. And this is supposed to be r squared. So all we have to do to figure out what r is just take the square root of this up here, which is 5. So we have the center of our circle and our radius. Now all we have to do is graph this circle. So we're going to put a point at 1 comma negative 5. We go over 1 on our x-axis, down negative 5 on our y-axis, put a point. We then have a radius of 5 units. So from our center point, we're going to go out 5 units to the right, 5 units up, 5 units down, 5 units to the left, and we trace our circle. We have now successfully graphed the equation of this circle in the coordinate plane.
What did the monkey wear when he cooked? An apron! Oh, you try...
Okay, doing the same thing. So we are given the equation of a circle in the coordinate plane. We need to find the center, the radius, and graph the circle. So we just need to compare this equation to the equation of a circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared is equal to r squared. If we compare these two equations, we can determine the value of h, k, and r. So we're going to start with h. This in here, in these parentheses, is supposed to be x minus h. Up here, we have x plus 4. Whoa, what would h have to be in order to make this a plus, in order to change the sign? It would have to be negative, meaning h would have to equal negative 4. What about y? Over here, in these parentheses, it's supposed to be y minus k, and we have y minus 2. Oh, this is easy. So k is going to equal 2. And this is supposed to be r squared. So all we have to do to figure out what r is just take the square root of this up here, which is 6. Now, because we have the center of the circle and the radius of the circle, we can graph this circle. We're going to put a point for our center at negative 4, 2. So we go over negative 4 on the x-axis, up 2 on the y-axis, put a point. We then are going to draw our radius. So our radius is 6 units. So we're going to go 6 units to the right. And now we go 6 units up, 6 units down, 6 units to the left. We trace our circle, and we have successfully graphed the equation of this circle in the coordinate plane. Now, example 4 says write the equation of the given circle. So it gives us the center of the circle and a point on the circle. So this question is exactly like what we did in example 2, in that it's giving us the center of the circle and it's giving us a point on the circle. The only difference is it's showing it to us instead of just telling us what those points are. So what we do is the exact same. In order to write the equation of a circle in the coordinate plane, we need the center of the circle and we need the radius of the circle. In order to find the radius, you need to find the distance between the center of the circle and a point on the circle. Now in example 2, what we did in order to find the radius was we used the distance formula to find the distance between these 2 points. So normally that's what you're going to do, except in this instance, both of these points have the same y value, meaning I can just count the horizontal distance between these 2 points. So how many units away is 0, 1 from 9, 1? Well, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, meaning we have a circle with a center at 0, 1 and a radius of 9. So we can then use that in order to write the equation of our circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared is equal to r squared. Our center is h comma k. So we're going to take 0, plug it in for h. We're going to take 1, plug it in for k. Our radius is 9, so we're going to take 9 and plug it in for r. We then simplify whatever we can simplify. X minus 0 we can just rewrite as x. Y minus 1 is just going to stay y minus 1, and then 9 squared is 81. And you're done.
What do you call an angry monkey? Furious, George! Oh, you tried.
Okay, part 8, we are again given the center of the circle and we're given a point on the circle, and we're tasked with writing the equation of the given circle. Well, remember, in order to write the equation of a circle in the coordinate plane, we need the center of the circle and the radius of the circle. Well, the radius is just the distance between the center of the circle and a point on the circle. And the good news again is that the center of our circle and the point on the circle have the same x value, meaning we can just count the vertical distance between these 2 points in order to find our radius. So our radius here would be 1, 2, 3, 4 units, meaning we have a center at 2, negative 3 and a radius of 4 units. So all we have to do now is plug those into the equation of a circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared is equal to r squared. So my center is h, k. I'm going to take 2, plug it in for my h, take negative 3, plug it in for my k. Then I take 4, my radius, plug it in for r, and simplify whatever I can. So x minus 2, that just stays x minus 2. Y minus negative 3 is the same thing as y plus 3, and then 4 squared is 16. Part B, I'm doing the same thing. I want to write the equation of this circle. In order to write the equation of a circle, I need the center of the circle and I need the radius of the circle. Now, I am again given the center of the circle and a point on the circle. So in order to find the radius of the circle, I need to find the distance between these 2 points. However, this time, the center of our circle and the point on the circle do not have the same x value or y value. Meaning, in order to find the distance between these 2 points, the radius of our circle, we need to use the distance formula. So we choose one of our points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. We plug in the coordinates to their corresponding spot in the distance formula. We simplify. We end up getting rad 9 plus 36, which is the square root of 45. Now, rad 45, we can simplify further because this says leave your radius in simplest radical form. So we need to simplify this radical. And the way we simplify a radical is we break it up into 2 radicals that multiply together to make rad 45. One of the numbers that multiplies together to make 45 has to be a perfect square. So what perfect square goes into 45? That would be 9. So rad 45. We're going to break up into rad 9 times rad 5. The reason we chose 9 is because it's a perfect square, and the square root of 9 is going to be 3. We multiply that to the rad 5, and we get that the radius of this circle up here is 3 rad 5 units. So now, in order to write the equation of this given circle, all we have to do is take that center of the circle, 1, 0, and the radius that we found, 3 rad 5, and plug it into the equation of a circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared is equal to r squared. I'm going to take my h, k, my 1, plug it in for h. My 0, plug it in for k. My radius is 3 rad 5, so I take that, plug it in for r. Now I just simplify whatever I can. X minus 1 is just going to stay x minus 1. Y minus 0, we can just rewrite as y. And then 3 rad 5, the quantity squared. Again, this trips up everybody, but it's pretty easy. You just square the 3 and square the rad 5. What's 3 squared? That's 9. What's rad 5 squared? The square and the square root just cancel each other out, giving you 5. So 9 times 5 then is 45. And you're done. Now example 5 says for each circle with the given equation, state the coordinates of the center and the measure of the radius. So we are given the equation of a circle in the coordinate plane and we need to extract the center and the radius. So the way we're going to determine what the center and radius of the circle are is we're going to rewrite this equation so it's in the form of the equation of a circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared equals r squared. So how are we going to get this to be that? Well, we're going to use a process called completing the square. So let me show you how this works. The first step is we have to put the x's next to each other and the y's next to each other. So we're going to take this minus 4x, move it behind the x squared. So it's going to be x squared minus 4x. Then it's going to be plus y squared minus 2y is equal to negative 1. So now we have the x's together and we have the y's together. Next, we're going to start completing the square for both the x's and for the y's. So the way you complete the square is you're going to have to add a number after the x's and add a number after the y's. Now remember, because it's an equation, whatever you do to one side of an equation, you have to do to the other side. That's why these are there. Now what we do is we figure out what these numbers are going to be. The way you figure out what these numbers you're going to add after the x's and after the y's are is you're going to take your b value, divide it by 2, and square it. And you may think, what is your b value? Well, remember, back to your Algebra 1 days, we have a quadratic trinomial here in the form of ax squared plus bx plus c, where our a value is 1, our b value is negative 4, and our c value is what we're trying to find. So we take our b value, which we said was negative 4, we divide it by 2, and we square it. So negative 4 divided by 2 is negative 2. Squared is positive 4. We put that number here. And again, whatever you do to one side of an equation, you must do to the other side of the equation. Now we need to do the exact same thing for our y values. This is in the form ay squared plus by plus c. So we take our b value, which is negative 2, we divide it by 2, and we square it. So negative 2 divided by 2 is negative 1. Squared is positive 1. So we put plus 1 after our y's. And remember, whatever you do to one side of an equation, you must do to the other side of the equation. Now you may be thinking, why in the world did we do this? Well, because on this side of the equation, we've created two perfect square trinomials, which we can factor into x minus some number or x plus some number, the quantity squared. Over here, we can factor this into y minus some number or y plus some number, the quantity squared. Meaning, we can put it in the form of the equation of a circle in the coordinate plane. So let's factor each of these and put it into that equation of a circle in the coordinate plane. So how do you factor a quadratic trinomial? Well, you learned in Algebra 1 how to factor a quadratic trinomial. You learned the magic x. You learned factor by grouping. You learned the box method. However you learn to factor this, when you factor x squared minus 4x plus 4, you get x minus 2 times x minus 2, which we can rewrite as x minus 2, the quantity squared. Same thing over here. When you factor y squared minus 2y plus 1, it factors into y minus 1 times y minus 1, which we can rewrite as y minus 1, the quantity squared. And then negative 1 plus 4 plus 1 is 4. We now have this equation up here in the form of the equation of a circle in the coordinate plane. So all we have to do to state the coordinates of the center and the measure of the radius is compare it to the equation of the circle in the coordinate plane, which is x minus h the quantity squared plus y minus k the quantity squared equals r squared. We look and we see that this is supposed to be in the form x minus h, and we have x minus 2. Oh, cool. So h is equal to 2. This is supposed to be in the form of y minus k. We look, it's y minus 1. Oh, awesome. K is going to be equal to 1. And our r squared is equal to 4, meaning our radius should be the square root of whatever this number is, which is 2. So we get our center is at 2, 1, and our radius is 2.
What kind of monkey flies? A hot air baboon! Oh, you dropped it!
Okay, again, we want to rewrite this equation so it's in the form of the equation of a circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared equals r squared. And the way we do that is through a process called completing the square. So we need to get the x's next to each other and the y's next to each other. So we take this minus 16x, put it next to the x squared. There is no y, which is awesome because what that means is that our b value is technically 0, meaning our c value, whatever we would add to the end of that, would also equal 0, meaning we only need to complete the square square for the x's. We can just leave this y squared. So what are we going to add to the end of the x's? Remember, whatever you add here, you got to add to the other side also. So how do we figure that out? Well, we take whatever our b value is. Remember, this is in the form ax squared plus bx plus c. Our b value is negative 16. So we take that negative 16 divided by 2 and then square it. Whatever that is, we put here. So negative 16 divided by 2 is negative 8. Squared is 64. And whatever we do to one side of an equation, we must do to the other side of the equation. Now remember, this is a perfect square trinomial, meaning however you want to factor it, when you factor it, you get x minus 8 times x minus 8, which we can rewrite as x minus 8 the quantity squared. Now what we see is that we have rewritten this equation up here in the form of the equation of a circle in the coordinate plane. X minus h the quantity squared plus y minus k the quantity squared equals r squared. So to determine the coordinates of the center and the measure of the radius, we just compare it to this equation. This is supposed to be x minus h, and we have x minus 8, meaning h is equal to 8. Perfect. This is supposed to be y minus k in the parentheses, but there are no parentheses. It's just y squared, meaning our k value is actually 0 in this case. And this is supposed to be r squared, and we have 64. So in order to figure out what r is, all you have to do is take the square root of whatever this number is. That should give you your radius, which in this case is 8, and you're done.